The patient weighs 146 pounds and is 63 inches tall. The prescribed medication is ordered at 45 milligrams per meter squared. How many milligrams have been ordered for the patient rounded to the nearest whole number? You see that metered squared? It typically means body surface area in our pharmacy world. So, body surface area, which is in meters squared, its formula is going to be the height of your patient in centimeters times the weight of your patient in kilograms over 3,600. And then all of that's going to be square rooted. So if we look at what we have about our patient, we know their height. They are 63 inches tall. And if we look at their weight, which we also have, they are 146 pounds. And what else do we know about? Well, actually, we know that we need to get our inches over 2 centimeters, and we know we need to get our pounds over 2 kilograms, because that's what's in our formula. And we know that 1 inch is equal to 2.54 centimeters, and that 2.2 pounds is equal to 1 kilogram. And using whatever method you want to use to convert that, but we get that our height in centimeters is 160.02, and our weight is 66.36 kilograms. So now we have our units in the right way that they have to be for that formula, so we can go ahead and plug everything in there. So now we know that our BSA for this patient is going to be 160.02, that's centimeters, times their weight in kilograms, 66.36 kilograms, over 3,600, and then we're going to have to square root all of that. So let's do it one step at a time, and if we do 160.02 times 66.36, we get 10,618.927. That's over 3,600, and we'll still have to square root all of that. If you go ahead and divide that 10,000 by 3,600, we get 2.949, and we'll have to square root that. And for most calculators, you can just tap that square root button and it should take the square root of whatever number is currently on the screen. So if I go ahead and tap square root, I get that the square root of 2.949 is equal to 1.717. And we know that's meters squared because this is our BSA. And so now that we have done that, we need to figure out how much this patient needs of this medication. And so my page is full. Let me just move on to the next one. So we know that our med is 45 milligrams over meters squared, and that our patient's BSA in meters squared is equal to 1.717 meters squared. And so you can either use dimensional analysis or that ratio and proportion method. So if we do dimensional analysis, we get 1.717 meters squared. If you can throw that into a fraction, that's just over 1, because any number is over 1, because dividing anything by 1 does not change the number. And so that, if we take that and multiply it by what our dosage is for this medication, which is 45 milligrams over meter squared, you can technically throw in a 1 there too. If we do this, our meter squared cancel out because there's 1 on top, 1 on bottom, multiply across, and 1.717 times 45 milligrams, multiply all that together, and you get 77.28 milligrams. And that's dimensional analysis. But if we go ahead and do that in our ratio proportion method, if that makes a little more sense for you, then we know that our med is 45 milligrams over meters squared, and we want something that looks the same. So we're looking for milligrams, so x milligrams over our meter squared, which for this patient's 1.717. Go ahead and do your butterfly method, and this turns into 45 milligrams times 1.717 meters squared, and that's equal to x milligrams meters squared. And if you multiply, let's move everything to one side first, actually. So we have 45 milligrams times 1.717 meters squared. And if we divide by that meter squared, we get that x in milligrams alone, and then our meter squared cancel out because there's one on top, one on bottom, and we're again left with 45 milligrams times 1.717, and that again equals 77.28 milligrams. And our question did say round to the nearest whole number, and if we go ahead and do that, then they're both equal to 77 milligrams.